Alright, welcome back. Hopefully you had a chance to try and set this one up. Now, we should always do with any compound interest problem, once you have the formula written out, is just think about what variables you have, like what parts of the equation you have, and what parts you need to figure out. So first off, we know the initial amount that we borrowed was $4,500. Right off the bat, we know that P is going to be equal to that. Okay. Now, again, the trickiest part with these problems is figuring out how to deal with I and N. So with their interest rate, remember that we have to take our annual interest rate, turn it to a decimal, so it's going to be 0.03. And it's compounded quarterly, which is 4 times a year, so you have to divide it by 4. Okay, and that one should reduce relatively nicely to 0.0075. So there's no need to leave it as a fraction. We can just do the division right there. Okay, and last but not least, we need to figure out what n is going to be. So we know whatever n is in terms of years, you have to multiply it by 4 because it's compounded quarterly. But again, I figured how many years we have. So we have 5 years and 4 months. So we have 5 years here. We have 4 months, which is 4 over 12, or 1 over 3. So if we work that out, we have 5 plus 1 over 3. We know 5 is 15 over 3 for finding a common denominator. Okay, so we have 16 over 3 years. Okay, so in terms of n, we're going to take the 16 over 3 years and multiply it by the number of compounding periods per year, which in this case is 4. So 16 over 3 times 4 gives you 64 over 3 compounding periods. So with all said and done, we have everything we need to put into the equation to solve for the amount of the investment. So our principal is $4,500. We're going to have 1 plus 0.0075, all to the exponent of 64 over 3. Okay, and A is already isolated. We should be able to run this all through our calculator. If you want to simplify first, you can. You can add 1 to 0.0075 first, then take the exponent, then multiply by 4,500. But when you run all this through your calculator, you should get $5,277.65 approximately. Okay, again, with money, we're going to try and round to 2 decimal places because once you get past the cent digit, it doesn't really make lots of sense. So that should be the amount that we owe after 5 years and 4 months. Okay, and again, you'll see the trickiest part here is, again, figuring out I and N are. Once you've got that, it's just a matter of running things through your calculator. If you're having troubles figuring this out in your calculator, come see me, and we'll run through that together, because, again, every calculator is different. Okay, let's do a couple more examples. So in this situation here, someone bought a used car by putting down $2,000. So they paid $2,000 right off the bat. And then 3 years later, they had to pay an additional $4,000. So we know the car was financed at 6% per year, compounded monthly. What was the purchase price? So again, what we know, and we know he paid $2,000. So when you're buying a used car, you have to have some amount of money to pay down. So he paid $2,000, and which means that whatever was left, he had to borrow. So he borrowed some amount, and so again, we don't know what he borrowed, but some time later, 3 years, he wound up paying $4,000. So the amount that he borrowed was worth $4,000 after 3 years. We need to know what he initially borrowed. So we know the car is financed at 6% per year compounded monthly. How much did he buy it for? So again, let's work this out here. So we know, again, that the amount he had to pay back is $4,000. Okay, as for I, it was 6% per year annual interest, so 0.06, compounded monthly, which was 12 times per year. So you divide those two, and that tells you that I is going to be 0.005. Okay, and last but not least for N, we know that it took 3 years for the investment to be worth $4,000, and so we take our 3 years and it was compounded 12 times per year, so N is going to be equal to 36. Okay, so we have everything we need. Let's put it into the equation and see what we get. So we know it was worth 4,000. We don't know how much he initially borrowed. You'll see what we have to do is eventually solve for p. So just to simplify the right side a bit, this gives you 1.005, all the exponent of 36. And if we want to isolate for p, this is what we need to divide both sides of the equation by. So I'm going to divide this side by that, so they cancel. Then again, we have to do the same thing to the other side. Okay, so run that through your calculator, let's see what we get. So I get approximately $3,342.58. Okay, so that would be the amount that he, or Rob, initially borrowed to have to pay for the car. So the actual purchase price of the car, well, it was the amount he had to borrow plus the original $2,000 he had to pay down. So the original price is the amount borrowed, the amount he was missing to make up the rest of that purchase price, plus the $2,000 he had originally put down. That's the amount he had on him when he went in to buy the car. So the total amount the car was worth when he bought it was $5,342.58. Okay, so how much interest did he pay? Well, for this one, it's not too bad a calculation, because we know he borrowed $3,342.58, and he ended up having to pay back $4,000. So the interest earned is simply going to be that difference. So he had to pay back $4,000. He borrowed the amount to cover up the rest of the purchase price, which is $3,342.58. Okay, when you run that through your calculator, you should get $657.42. Okay, let's take a look at a couple more. So in this situation here, we're giving you a table of values. So his monthly bank balances are shown below. And he's in a bank account that's where the interest is compounded monthly. We want to figure out a couple things. How much did he originally invest, what was the annual interest rate, and again, how much interest he'll have earned after 6 years. So the one thing we need to point out here is we're not given a principal here. That's what we're trying to find. We're not given too much else here. Okay, so the best way to attack this one is to actually exploit the fact that we know that if it's compound interest, it's exponential. So if it's exponential, we know there's a constant ratio between the different values in the table of values. So let's take a look here. Let's see what happens if we divide $7,545.09 by the value for month 2, which is 7530.03. So if you do that division, you get approximately 1.002 for that common ratio there. Okay, so now let's see if it's the exact same thing as we go down from month 2 to month 1. And it should be, because it's compound interest, but we should always double check just to make sure we're on the right track. So we go 7,530.03, and we divide that by 7,515. And again, you wind up with 1.002. So that's our constant ratio here. And what that also means is that we can go one step further and extend the table up to month 0 by dividing 7,515 by 1.002. So if we do that, it should give us what that initial investment was, which tells me it should be $7,500. So that's one way of going about it. The other way you could have done this is, one of the things we looked at last unit is that, when you have a common ratio, that value is equal to the base in the exponential function. So whether we could approach this, we could have said, okay, using that a equals p times 1 plus I to the n, we know that the value of the base in the equation is going to be equal to a constant ratio, so we know that's going to be equal to 1.002. Okay, and then we can take the value for any month that we want. So let's just say we want to take a look at month 1. Well, in month 1, the value of the investment is 7,515, and that would mean one compounding period has passed because it's compounded monthly. So we could actually take this equation, solve it for p, and get the exact same answers. Whichever way you find easier to think about this problem will work. But again, either way, you should wind up with a principal investment of $7,500. Okay. So with that in mind, what's the annual interest rate? Well, the best way to look about this one is if we know that the value of the base is 1.002, we know that 1 plus I is equal to 1.002. Okay, so that means we can actually take this equation and solve for I. So if we subtract 1 from both sides of the equation, that tells us that the value of I was going to be equal to 0.002, which isn't exactly earth-shattering. Okay, but remember that, again, we're looking for the annual interest rate, and since this is compounded monthly, we had to take, in order to get this, I would have had to take the annual interest rate and divide it by 12. Okay, so again, putting this into the form of an equation we can solve, that means whatever our annual interest rate, which was R, we had to divide it by 12 to get that value of I, which was 0.002. So it means that 0.002, if we multiply it by 12, we should get our annual interest rate. So 0.002 times 12 is equal to 0.024, which if you multiply by 100 gives you a percentage of 2.4% per year. Okay, so once we have that in mind, now we can answer C relatively straightforwardly. So how much interest will Brandon have earned after 6 years? Well, again, now we know our principal is $7,500. We know our I is going to be 0.002. We already knew that one. Our N for 6 years, well, it's going to be 6 years compounded monthly, so 6 times 12 is equal to 72. So everything we need to calculate the total amount of the investment. So A is going to be equal to 7,500, which is P, 1 plus 0.002, the exponent of 72. So you can quickly run that through your calculator and figure out what the total value of the investment is. So that should give you about $8,660.39. Okay, so how much interest we have earned? Well, again, this is the total value of the investment, so his interest will be the value of the investment, which is the $8,660, minus his original investment, which was $7,500. Okay, and that amount should give you the interest he earned, which was about $1,160.39. Okay. So a lot was going on in that question, but again, what was different here is once you have the table, even though it's not giving you a lot of information explicitly, you can still find out everything you need to know about what's going on with the investment. Okay, there is now one last example to try. Probably not enough time for me to do it in the time that's left, so why don't you give it a try on your own, and it'll just take us a couple minutes to go through it together. We'll go through that in part 3 of the lesson. We'll see you over there.